There we go. We see them.
Okay, thanks. So I'm Victor Blanchi, and I am a student in the ENS, and I will talk about the work I've done with Hugo Paquet.
Sorry to interrupt. Can you also turn on your camera?
I think we can't. I'm sorry. We don't have the camera. Okay, I will talk about the work I've done with Hugo Paquet in my internship. So the question was, what are polymorphic programs of type prob A to prob A? So this kind of program take a measure and give us and returns a random measure. So why are we interested in this kind of programs? We are interested in this because of program of like Dirichlet process, which is often used for modelizing non-parametric clustering. And I will give you, I will explain how it works. So if I take A, like all the color, like the set of all colors, and I give a measure new on these colors, I can return with Dirichlet process a random measure by first sampling a sequence of weights, so W, according to a stick breaking procedure. This sequences has to sum to 1. Then I sample a sequence of IID from the base measure new. And then I return the thing we can see on the right. So the sum of that Dirac measure on xn with weight wn. So the question is this kind of program the more general we can have? And to do so, we will formalize polymorphic program of this type with category theory. Prob is a monad, and we will say that we will modelize this polymorphic program as a natural transformation from prob to prob. So it just means that we want this diagram to commute for every morphism F for M to B. And what we've shown is every natural transformation from prob to prob is in fact something which looks like the Dirichlet process. So we define homogeneous random distribution. So if we have distribution phi over nabla, which is the sequence of weights which sum to 1s, we can sample from this thing, then sample from the base measure nu, and then we'll just have a part which is discrete, and we do the same thing as the Dirichlet process, and the other part which is just the base measure. And so every natural transformation of this form. Okay. Thank you for your attention. Okay.